Okay, everything we've done is to get up to this point, pretty much. You're going to use this quite a bit when you add up forces, and there's lots of ways in which you're going to use this, lots of applications. Vector 7, we're going to add and subtract by components. That's how we usually do it, usually not a scale diagram. We're going to divide and conquer. If you have a lot of work to do, you divide it up. You do a little bit here, and a little bit here, a little bit, maybe you're in a team. Okay, you guys do this, we'll do that. We're going to divide our vectors up into parts, right? Perpendicular parts. Using this method, if you're careful, like if you want to shortcut anything, you got to trust that this method will catch mistakes for you. It'll be easy to catch your mistakes. Or if my student brings me something and they've done this method, I go, ah, I see. You've dropped a plus sign or dropped a minus sign or something. Any mistake. You use cosine when you should use sine, whatever it is. You'll be able to catch any confusions, any misconceptions that you have, because it'll come out like in little bits. You'll know exactly where your thinking is a little bit off. It'll train efficient thinking. It'll help you win prizes, and it'll make you happy. So, okay. So here's all you got to do. And really, if you have a method, then you can go through things faster. It doesn't take you long. Say you want to add up 3 vectors. Now you can do 4 vectors. You can do 2 vectors, whatever it is. And the vectors could be anything. You could add up velocities, displacements, electric fields. Who knows? Okay. So I'm going to use a displacement from state 1 to state 4. That's the total displacement, sometimes called the net. Also the resultant, as we saw last time. And the displacement from state 1 to state 4, position 1 to 4, is equal to the sum of the displacement from 1 to 2, displacement 2 to 3, displacement 3 to 4. Right? So vectorially, I can write that equation. Fine, I could move that around if I wanted to solve for this one. I could subtract the other ones and do whatever. All right. Whatever I know, I'll use to find whatever I don't know. So if you put it into this table, it's very, very, as I say, methodical. We've got polar form and converting into component form. If you know the components, well, fine, you could just write it in. If you don't, you're going to have to take your polar form information and go into your component form. But the goal is to put it in the component form. That's the first step. So what I've done here is, and let me separate this all the more, is to say, wait a minute. It's the same vector. I can take them one by one. The magnitude, or the amount, with units. For velocity, the amount's the speed. For force, the amount's the strength. For displacement, the amount is, as you know. So if you've got a number, great, put it in. Don't forget the units. If you don't, leave it as a symbol. Just put it in as a symbol. If there's an equation, which you're going to see with forces, well, put that in. And whatever you've got, just put in what you know, symbolize it, and work from there. Okay, so here's the displacement 1 to 2, displacement 2 to 3, displacement 3 to 4. But this is just the amounts, right? I don't have the vector on top of it. You can put absolute values on. So here's the magnitude with units. And anything you know, and then there's stuff that you don't know. Fine, don't worry about it. And then sketch it. So you've got the magnitude and direction, polar form. The direction, you want to show it with a sketch, if you can. If you don't know it, well, fine, just move forward. It's a puzzle. Some pieces will be missing. You've got to find those. So for example, D1 to 2, I just drew it. Let's say it's there. So I sketch it, and let's just say I'm using my good old XY coordinate system like this. Okay. Then D1 to 2 is here. The angle that I'm talking about is here, so I need to see that. It'll be given, or you look for it. And so that has components. I've drawn purple for the X component, and a red or pink for the Y component. And I can see it now. Once I draw that, I'm good. Okay. And D2 to 3. Now 2 to 3 is kind of a clunky notation. I mean, you know what it means from state 2 to 3. You might just want to call that D2. That's okay as long as you know it's from 2 to 3, whatever. Okay. So suppose this is going off at some angle alpha. Maybe I know alpha, maybe I don't. I don't know, I'm just putting it in here. Well, it's going up some and over some. And of course I can make a rectangle out of that, I can do over sum and up sum. And now I can see how the components relate to the magnitude and the angle and the coordinate system, the plus minus directions. That's what I need. If I do that, I'm going to be clear. If I'm having trouble doing that, then there's something I'm missing. And that's a good place to ask a question or to reread the problem. If that's hard, then you're missing something. Good. Now you can dig into that because you need to know that. The third vector, the fourth vector, the fifth vector, all of them, sketch them. This one I've sketched this way, just say it's given. And you can label it. I need to see the relationship between the components and the angle and the magnitude. 3 to 4. Again, that gets a little clunky. So what do? I take each vector, divide and conquer. So I divide it, I go from polar form to component form. Now here I did, I said d1 to 2x. That's a little hard to write, so maybe I'll just call it d1x. d2 to 3, I'm just going to call it d2, the second displacement. From 2 to 3. So, however, now let's take a look at that. Oh, I can see my triangle. You know how to do this. d1x, that's this purple part, right? So I drew it purple. And what is it? Well, is it in the positive or the negative x direction? Oh, I see. If it's 0, I mean, if it's all going this way, just put 0. Sometimes it's all in one direction. Fine. And you can see it. But this is going some in the x. In fact, it's going in the positive direction. I put that explicitly so I know I'm checking. How much? It's going d1 or d1 to 2. So I'm going to call that d1 now. Oop, I better not put an x in there. And if I use this angle, do I use cosine or sine? It's adjacent, so cosine theta 1. And if I have a number, some meters or whatever, put it in, fine. If you don't, leave it and you'll solve for it. How about in the y direction? Positive or negative? Ah, that's also in the positive direction, d1 sine theta 1. If I use cosine of the angle here, I'll use sine there. Equals, if you have a number, fine. If you don't, just keep going. Every one. d2, x. Wait a minute, the purple is going in the negative direction. So I need to observe that from my sketch and put it in explicitly. How much is it? It's the magnitude, 2 or 2 to 3 if you want to write it. Notice that the x component, the purple, is opposite alpha. If it's opposite, then I use sine of alpha. So be sure to realize that you can have sine, you can use the sine for x components too. Just your picture will tell you. You don't even have to think about it. It's right there. Once you've done this, it'll reveal itself. And again, you can put in numbers if you've got it. And in the y direction, it's positive d2 cosine alpha. I don't even have to look at the picture because I use sine alpha here. It'll be cosine, but I do have to look at it for the plus and minus. And then I do it over here. Let's just do that really quickly. You can do it probably. Right, d3. Oh, that's going in the negative direction. Here's the magnitude, but the part is less than the whole, so it's opposite phi. That's the Greek letter. Goes like this, spelled like this. The Latin pronunciation will be phi because the I is pronounced E, like Maria. Some people say phi, whatever. It's opposite, so that means it's sine also. If I use this angle or that angle, then it'd be cosine. In the y direction, oh, that's negative as well. The magnitude, cosine phi. And then if you got the numbers, good. So that's how you do it. You take them one by one, magnitude, put in the variables, and put in information you know. Sketch it, get the components. Now it's in a table. Why did you put it in a table? Because first off, you want to have an organized way. And second off, since these are all going in the x direction or negative x direction, I can add them up. And so the resultant, or the net, or the total, whatever you want to say, the sum of the x components is equal to the net x component. In some problems, you'll know what that is, and you'll be looking for this, but you can still write an equation, this plus that equals that. And you get to do the same thing here. So you take this whole column, add it up, and that gives you the total in the x. And then you take this whole column, add it up, and that gives you the total in the y. Now you've got it. You've got the total in component form. Now you might want to know what the total amount is and direction. Because that really kind of tells you a little bit more. Component form is fine, but it's like, well, how much and which way? So that's the third part. Convert back, it's just a vector, from component form to polar form. Sketch it. It'll help you so much. Like if this is a negative number, then sketch that component that way. If this is a positive, that way. If this is negative, in fact, if I look here, I'm going positive, but then I go negative and negative. So I think I'm going to end up going negative, and I'll show my sketch in a second. Here I go positive, positive, and a negative, but it's probably positive. So I'd sketch however much in the x, plus or minus, however much in the y, and piece it back together. Let's take a look and see how we do that. You know how to do this, but it's a nice review. And then you really don't know it until you've done it a bunch and you kind of smoothed it out. So I've drawn, okay, in the x direction, that looks like a y to me. The net, after I add up all the x part, the purple, is in the negative direction. And then in the y direction, I said, it looks like I got a positive y, so I could do it here, or I could do it here. To add them, I've got to go tail to tip, right? Or I could do it here. But the result, this is a common mistake. You cannot connect, you don't want to connect the tips unless you really know, unless you're doing the right thing and subtracting or something. The result is to the left and up. Therefore, I'm going to draw my result. From here, I didn't label it, but this is d net y. And so the result, I like to draw as a double arrow, just to emphasize that point. That's d net. How much is that? Oh, it's the square root of d net x squared plus d net y squared equals, don't leave off the units. And pay attention to sig figs and precision, right? Okay, good. Oh, well, maybe I want an angle. Which angle do you want? Do you want this one? A? Call it whatever you want. Or do you want this one? B? Which is also this one, right? B. So you got to know your angles. I don't know. Whatever. If I want A, then I know that the tangent of A is this over this. So that's d net y over d net x. Again, I would use absolute values, and then I'll get a number less than 90 degrees, and I can show which way. So what does that give me? Oh, of course, that gives me that A, the angle, is the inverse tangent of the y component, d net y, over d net x. If I want B, well, if I already have A, then it's 90 minus A. If I don't, if I want to get B first, it doesn't matter. Then I can say B is the inverse tangent of x opposite over adjacent. And so I hope what you see is that the picture will guide your thinking. You won't be just stuck in your head, because you're going to make a mistake. There's too many puzzle pieces. You can't solve a puzzle without moving the pieces around. You can't just do it in your head. If you do this, it's doing everything we've done one by one. You take each vector, break it into the parts. Now you add up all the x parts, and that's the total x. You add up all the y components, and that's the total y. You put those together and you got the result, the total x and the total y, which are perpendicular, so they're related by the Pythagorean theorem, and the angles are given by the inverse tangent. It's the same thing over and over again. But now you get pretty good at it. You know this tool and you really can put it to use. Then little puzzles come up where, like I say, maybe you're given the resultant and you're looking for the missing vector. So write an equation and then maybe move it around and whatever, and just write what's true and then go from there and find out. But make sure you write down, what do you know? What do you know? Show it on a picture. Is that sine or cosine? Is it positive or is it negative? What are the units? Be real careful in your training, care and attention to detail. Remember, the glory is in the details. That's how you work it out. So, and we always make little mistakes, so it's nice to be able to go back and catch them. If you haven't written it out, you won't be able to, and you won't be able to work together. You can do this. We'll get lots of practice. So start out, and you will be old hat soon. Go Vectors.